Today's lesson, I want to look at the schedule. So today we're doing lesson number 6, which is equations of lines. And next time I see you, which is Wednesday, right? Because Monday's President's Day. So on Wednesday is your first quest, right? That's an in-class quiz/test, cross between a quiz and a test. You were allowed for that quest to bring 1 page of notes with you. You can write anything you want on it. And you can use a scientific calculator. Right? If you happen to have a graphing calculator like this one, not allowed, right? You can use a calculator like this. If you don't have one like this, I can lend you one for class. And no cell phone calculators either. So remember, 1 page of notes, write whatever you want on it, bring it with you to the quest. Are you going to have calculators tomorrow? Yes. What are we supposed to be caught up with homework? So it's going to be on lessons 1 through 5. So what we talk about today will not be on the quest, but everything before today is on the quest. So I would make sure that you have done homeworks 1 through 5. All right, so let me write a few things down here on in the notes so that go away. So quest 1. It's on lessons/homeworks 1 through 5. Okay. Bring 1 page, 8 by 10 or 8 by 11, whatever, 1 regular normal piece of paper of notes. Not required, but I strongly suggest it. You can write on both sides. Yeah, you can write on both sides, and you can write anything you want on it, but you have to write it or type it, but you have to create it yourself. No. It should be written on when you come in. It'll be covered with your notes that you want to be able to refer to when you take the quest. Yes. Yeah. You can bring 1 page, anything you want written on it, to the quest. I will have some calculators to lend you if you don't have your own. Yeah. Scientific calculator only, and I will have some available to lend. All right, so in terms of preparing for the quest, you have a lot of material that you can refer to for studying. You have your packet that we've been working out of, right? So if you didn't do the even more practice section on any of the lessons, those are some problems you can do. You can always go back into your homework. You're not restricted from going back in, and even problems that you already got right, you can click try a similar problem. So you can do that. So you've got your packets, you've got your homeworks. In addition to both of those things, if you look at this schedule, and I have a couple more if people have lost theirs, so we've got a column for the dates, and each date is labeled with a lesson number, right? And right next to the lesson number is a thing called practice problems. Okay? So I gave you a packet on the very first day of class that was called practice problems. It looks like this. Practice problems for Math 096. So these are practice problems from throughout the entire course. To find out which ones match up with the material on the upcoming quiz or test, we look at the syllabus calendar. Okay. So the syllabus calendar, if you want to do some more practice problems from lesson 1, go to the packet and do number 1. If you want to do some practice from lesson 2, go to your packet and do numbers 4 and 5. Yes?
Are copies of the packet, and are those up on Moodle, or are there any other resources there?
Yes, I was just going to say that. Thank you. So the packet itself, if you've lost it, is in Moodle. So this is our Moodle site. Let me just quickly this. If you scroll down to the bottom of our Moodle site, this last block is sample, quest, and test materials. So this is the practice problems packet. You should have a hard copy of this already if you were here the first day. If you've lost it, it's here, you can print it. There's also a version with all the solutions written in. So let me pull that up so you can see. This is the packet with all the problems solved, work written out. So you can refer to that if there's anything that you can't figure out. That's only on Moodle. I haven't printed it. Yeah. There are answers, just not all the work written out. Yeah. And then also in Moodle, in addition to having the answers all written out, there's a link to a YouTube playlist where there's a video of each of those problems being solved. Okay, so click that. There's also videos of this class. Yeah. Yeah. So this is the playlist of problems from that packet. So you can watch. Ian, I believe, is solving all of these. Yeah, and I'll just show you quickly. I don't know if I've ever pointed out in our Moodle site. This is the link to the playlist of class videos. So if you missed a class, you click there, and every class has a video of the demo part, just the part where I'm standing at the board talking. All right, so you have lots of resources to help you prepare. My suggestion for studying is as you go through the even more practice, as you go through the practice problems packet, as you go through any homework problems that you go back and try again, as you're doing all of this practice, jot down anything that you needed to look up or that you had to ask somebody or you had to refer to the solution because you couldn't remember how to do it. Write it down on your one piece of paper that you're allowed to bring to the test. So hold on. So then you'll have this paper, right? And it has everything on it that you had trouble with while you were studying. Then I would study all of the problems again. Do them all again fresh, where the only thing you're allowed to look at is that one piece of paper. Does that make sense? So pick at least a few problems from every class. Maybe you're going to use this packet, right? Maybe you can focus on the practice problems packet. And as you go through each of these practice problems from the packet on classes 1 through 5, jot down anything that you needed to look up or couldn't remember. Then do all of these problems a second time, where the only thing you're allowed to look at is that paper that you created, and make sure you can solve them with just that. So that's my suggestion for how to study. Okay? All right, so don't forget, next class, Wednesday, Quest 1. Okay, so let's start on lesson 6. Remember, anything we talk about today is not going to be on Quest 1. Okay, so today's lesson is not on the Quest next class. So if things get confusing today, you can at least say, well, at least it's not on the Quest, right? All right, so today we're going to make extensive use of the slope-intercept form of a line, and we're also going to see a point-slope form of a line. So we're going to be talking about equations of lines. So here's an important note. In our textbook, we're going to skip sections 2.1 to 2.3. They cover a mathematical topic called functions, which is a concept that isn't part of GCC's curriculum. It's never been a part of this course, so we're skipping it. But occasionally, the textbook will refer to the word function. And if you ever see the word function in your textbook, just mentally replace that word with the word equation. Okay? And if you ever see symbols that look like F parentheses X or G parentheses X or H parentheses X, replace those with the letter Y. Okay? So for example, if you read in your homework, consider the function f parentheses x equals 3x plus 2, you would translate that to replace the word function with the word equation, and you would cross out the f of x and replace it with a y. Right? So it would say, consider the equation y equals 3x minus 2. Yes?
Why are they changing?
The concept of a function is a really important concept, and we introduce it at GCC in the next course, College Algebra. It is not just to mess with you. There are good reasons for having a new notation, but we don't need them now. We don't need it now.
But it's the same.
It means the same thing. Yeah. Okay, so moving on to the start here. The slope-intercept form of a line. If we want to write an equation for a line, it's going to have the form y equals mx plus b. Okay, the slope of the line is the m, so the m represents the slope of the line, and we talked about slope last class. So the number touching the x is the slope, and the y-intercept of the line is b, or the point 0, comma b. So I want to write an equation in slope-intercept form of a line that has a slope m equals -2/5 and a y-intercept 0, 3. So I'm going to start by just writing the general equation of a line, y equals mx plus b. And then we do some substituting. We replace the m with the number that it equals, right? So m equals -2/5. So I can replace the m in this equation with a -2/5. Okay, and then I replace b with the y-intercept, right? So the y-intercept is a point, but I only use the y coordinate of that point in my equation. So what am I going to put in for b here? 3. So there's the equation of a line that has a slope of -2/5 and a y-intercept 0, 3. So that's just the general thing. You replace the m with the slope and the b with the y-intercept. Now figuring out what m is what we talked about in the last class, how to calculate m. So let's find the equation of a line that passes through these 2 points by following this general process. So first thing you're going to do is circle both coordinates of a point on the line. We have 2 points. You can pick either one. Right, so I've got -1, 4, and 2, -5. Which one do you want to circle? Okay, I got requests for both. So I think in your packet this is done for you, right? They circled -1, 4. So I'm going to circle that one just to match what it did. All right, so I circled -1, 4. That's done. So part B, step B, write down the slope of the line, right? So remember, the slope of a line is the change in y over the change in x. So change in y divided by the change in x. So we got to subtract the y coordinates. So and subtract the x coordinates, and we just have to remember to do it in the same order. So if I do 4 minus -5 for the y's, I did this y minus this y. Then what's my what subtraction has to go on the bottom? -1 minus 2. Okay, so we simplify that. What is 4 minus -5? 9, right? Because minus a negative is really adding. So 4 minus -5 is 9. What is -1 minus 2? -3. 9 divided by -3 is -3. Okay, so there's my slope. M equals, it's my slope. So I got the slope part. Now write y equals mx plus b. No substituting, just y equals mx plus b. In that equation, I'm going to replace the m with the slope, right, which I just calculated was -3. So I'm going to replace my m with a -3. So it's always going to look like y equals some number plus some number times x plus b here, and put a star next to this equation. Now, rewrite the equation from the previous step, but replace the x and the y with the coordinates of the point that you circled in step A, right? So every point on the line is an x, comma, a y, right? So in your equation, you can replace the x with the x coordinate and the y with the y coordinate. So I'm going to replace this y with a 4. And then x with -1. And b, I still don't know. Now that's an equation that I can solve for b. B is the only unknown in that equation, so I could solve for it. So let's simplify a little bit. What is -3 times -1? +3, yeah. So we have 4 equals 3 plus b. So what does b have to be? 1. Subtract 3 from both sides, and you get b equals 1. We're going to bled into my next line here. B equals 1. Okay, it's really tempting to circle b equals 1 and just move on because we're so used to solving equations and that being the answer. But we're not done yet. One more step. One more step. You have to go back to the equation that you put a star next to, replace b in that equation with the number you just solved for. Right? So I'm going to have y equals -3x, and instead of plus b, now I put plus 1. Now I'm done. That's the equation of the line. So that's the general method. It's all written out for you here. You've got the example done out next to it. So when you go to the activities, you can follow that if you need to. All right. And of course, there's always more than one method, right? There's always more than one way to do this. So we have one other way that I'm going to show you today to find the equation of a line. So if you have a line that has slope m and goes through a given point, x1, y1, then you can find the equation of its line by plugging into this formula. Instead of y equals mx plus b, this is equivalent to y equals mx plus b. So you do y minus your given y coordinate is equal to the slope times x minus your given x coordinate. And this is called point-slope form because it uses a point and the slope. All right, so we'll do this exact same problem that we just did with mx plus b using our new form. So step 1, find the slope of the line. We already did that, right? And it came out to be what, -3? Yeah, m equals -3, because these are the same 2 points that we did in the last example. See previous example. All right, then rewrite this equation. Y minus y1 equals m times x minus x1, but replace the m with a -3. So I'm going to have y minus y1 equals -3, parentheses, x minus x1. Next, replace the x1 and the y1 in the equation with the coordinates of a point on the line. Okay. If you have 2 points, you can just pick one. It doesn't matter which, right? So let's pick the -1, 4. I'm going to replace y1 with a 4 because 4 is the y coordinate. And I'm going to replace x1 with -1 because -1 is the x coordinate. So this is going to be y minus 4 equals -3 times x minus -1. Okay. Then we just simplify this thing and solve for x. So I have y minus 4 equals -3 times, instead of minus a negative, I'm going to write a plus, right? Minus a negative is the same as adding. Then distribute your 3 and solve for the y. So I have y minus 4 is negative 3x minus 3. Add 4 to both sides, and you get y equals negative 3x plus 4 plus 4 plus 1. And that's the exact same equation we got with the other method, right? Negative 3x plus 1. So you can use whichever method you like better. Pick one and go with it, or try them both, whichever one you like. All right, so that's it for the demo. You can start on the activities. Yes, Tara.